Hi, hello, vanakkam, and welcome back to yet another episode on Little Slaw YouTube channel. So, in this video, we're going to see about the client server model architecture. Before that, we will see what is a client, what is a server, and how do they connect, and what are the advantages and disadvantages of the client server model. So, before we move on to the video, this is me, your son Shanmugam. Please do like our Little Slaw YouTube channel if you have not subscribed yet. Like, comment, share your questions and feedbacks in the comment section. So first let's see what is a client in the client server model. A client is a computer program or device that requests services or resources from a server, which is another computer program or device that provides those services or resources. Basically, the client server model is a distributed computing architecture where clients and servers communicate with each other over a computer network. The clients initiate communication with servers by making requests for data or services, such as sending a web page request to a web server or requesting a file download from a file server. The server responds to these requests by providing the requested data or service to the client. So, what are the examples of a client applications? So, they include a web browser, an email client, a file transfer client, and a database client. So, let's now see what is a server. So far we saw about what is a client, and let's now see what is a server. A server is a computer program or device that provides services or resources to the client, which are other computer programs or devices that request those services or resources. The server is responsible for managing access to shared resources and ensuring that clients can access the resources they need. These servers typically run continuously, providing services to multiple clients simultaneously. When a client makes a request for data or services, the server responds by providing the requested data or service to the client. So let's now see some of the examples for server applications, which include a web server, an email server, a file server, and database server. Web servers provide web pages to web browsers. Email servers manage the delivery of email messages. File servers provide access to files, and database servers manage access to databases. Servers are often more powerful than clients and are designed to handle high volumes of requests from multiple clients at the same time. They typically have more processing power, memory, storage, and network bandwidth than the clients. So far we saw about the client and the server. So how do they get connected? What is connecting the server and client? So for that we have the networking devices. The framework calls for physical or wireless networking devices like hubs, switches, and routers to connect the servers, clients, and any other resources. With the connection between the clients and servers established, administrators can configure how client devices make requests and designate servers to complete a specific task or tasks. So let's now see what is a client server model. So far we saw about what is a client separately, what is a server separately, and how does a network device works, and we also saw about some of the examples as well. So let's now see what is the client server model. So the client server model is a network architecture that describes how servers share resources and interact with network devices. The client server model describes how network devices like workstations, laptops, and IoT devices known as clients make requests to network machines or software capable of completing the request known as servers. Those servers historically have been physical appliances like rack servers or data centers. Shows these administrators increasingly deploy virtual servers for a range of workloads. So let's now see what are the components of a client server. So all client server frameworks contain three primary ingredients. One is the client, the server, and then the networking device to connect the two segments. And let's now see some of the examples. So for example, when we have a workstation which connects to the server, a database server, we connect it through a hub. And when we have a desktop that connects to a DNS server, we have a bridge. And when we have a laptop, it connects via switch to the web application server. And when we have a tablet as a client, it connects to the file server through a router. And a smartphone connects to the proxy server through gateway. And the IoT device connects to the virtual machine through a modem. So far we saw about what is a client server model and some of the components, some of the examples of some of the components of a client server model. And let's now see how does the client server model work. A client server architecture follows the process. Say for example, a client submit a request through a network enabled device. The network server receives and processes the request. The server delivers a response to the client. Though this looks very simple, the client server model is widely applicable and relevant to anyone looking to understand the CDN, which is the content delivery networks, or the mechanics of edge networking. As server capabilities move closer to the network edge, the client server process is physically closer to end users. So let's now see some of the examples of the client server models. The very first example is our email, the email that we use. So communication is essential to enterprise organizations, and mail cannot compete with the speed and reliability of electronic mail. The ordinary emails cannot compete. We all know that with the speed and reliability of the electronic email. So the hosting of email communications for an organization or network by a specific server has been the long time industry choice to control particular email accounts and activity. Through protocols like IMAP, POP3, and SMTP, administrators can establish a system that facilitates, secures, and maintains email communications. When using their email accounts, staffs are the clients which make requests to send emails, upload attachments, and store contacts to an email server. And taking to the second example, which is accessing web content. When a web client wants to access a specific website, they enter the URL and the browser requests an IP address from the domain name system. The domain name system server assigns the user an IP address for identification and delivery of results. By navigating to the website, a client triggered specific web content that the user can only access via an HTTP response provided by a web server. In this case, the end user is the client presented with digital content. The DNS server and web server establish and facilitate the connection to a database hosting the web content. So we saw some two examples of how the client server model works. And let's now see what are the advantages and disadvantages of the client server model. So when talking about the advantages, it has a central access and the control of data is in the client server model. On the other hand, the client server model has less control of some network devices. So when talking about the next advantage, the client server model are efficient, they are scalable, and they are organized system. On the other hand, the upfront cost and implementation is huge, and that is another major disadvantage of using the client server model, which is the upfront cost and the implementation. And when talking about the advantage, we can use the load balancing for optimal performance. And on the other hand, the disadvantages of the client server model is that the technical expertise is required for ongoing maintenance. When coming to the next advantage, The client server model provides the redundancy and data recovery options. But on the other hand, the disadvantage relies on the same area where the servers are always at risk of DOS attacks. So, when talking about the last advantage, which is this client server model or interconnected network of devices. On the other hand, the clients are attack vectors when breached. So it all depends on the advantage and disadvantage. And if you are comfortable with the advantages, you can choose the client server model. And in case if you are not, you can ignore the client server model and you can go for the next options. So let's now see the different types of client server architectures. There are 4 types of client server framework of how the client server relationship evolved with networking advancements. So the first one is the one tier. We all know about the one tier, which is an all in one system. So all client server configuration settings, all the user interfaces, the business logic, the database logic, everything sit on the network devices in the base client server architecture. And this is often limited to smaller networks where the one tier frameworks include presentations, business, and data access layer on the same machine. And next comes the two tier where we have the client and server. So in the two tier architecture, we add a server to the mix and separate the presentation layer to a user interface where the client makes requests outside its capabilities. Clients and servers take on more business and database logic at varying levels, providing administrators some control. And then comes the third tier where we have a middleware. So to avoid any of these security issues and to keep it further protected and secured and by enriching the two-tier architecture, this framework, which is the three-tier framework, incorporates middleware between the client tier, which we call as presentation layer, and the server tier, which is the database layer. And this application layer provides a third tier which enables more complex management of business logic. And some of the examples of middleware like web application servers, which offer load balancing, increased storage, and security. And these are the advantages of having a middleware. And then we have the latest one, which is the N tier, or we call it as multi-tier architecture, which is working off of the 3-tier architecture. The N tier describes the further use of middleware to segment network traffic and functions. Though this comes with greater complexity, modern enterprise organizations require multi-tier architectures, flexibility, scalability, and security. So far we saw about the different types of client server architectures, the advancements, the advantages and disadvantages of them. And now let's see the difference between peer-to-peer versus client server. So what is the difference between a peer-to-peer and a client server architecture? Though the client server framework is the most popular distributed architecture, the most common alternative mentioned is peer-to-peer, which is P2P networks. So unlike the client server architecture, which offers a centralized flow from an organization's servers to staff, stakeholders, and clients, a peer-to-peer network is decentralized. And all the network devices, they don't align with a specific dedicated server. Instead, this P2P, which is peer-to-peer network, include network devices, which we call as clients, known as nodes, that submit and service requests between each other. Because peer-to-peer networks like blockchains work in a distributed fashion, connectivity is critical to operations relative to traditional networks. Nodes tend to be more heterogeneous and share less data across the network. The client server model is more expensive to set up and maintain, but the reliability and scalability of the centralized framework consistently outweigh the downfalls of peer to peer frameworks. So let's come to a summary about the distributed architecture of choice for enterprises. With benefits like centralized data control, workload balancing, added security and redundancy, the client server model is the near universal framework for SMBs to enterprise organizations. When compared to peer to peer networks, it's easy to see why the client server model scaled digital operations for networks to this point. As organizations grow, adapting additional tiers of client server architecture is necessary to maintain IT infrastructure and secure data integrity properly. To serve millions of customers and stakeholders globally, enterprises need a robust, distributed framework that only the client server model provides. So, with that, we come to an end. I thank you all for watching the video. Until I meet you in another interesting video with another interesting topic, it's bye bye from Vasant Shanmugam and Little Slaw.